Heroku. I focus on Heroku Connect, and I'm fortunate to be joined today by Howard Burrows, who's a principal engineer on the Connect product and actually a founding member of the team that created Heroku Connect. So Connect began its life outside of Salesforce, and Howard was a part of that original team. I'm relatively certain you've seen this slide a few times in the past day and a half, so essentially, as you probably heard many times, any purchasing decisions should be based on generally available features. For the most part, we're going to stick to those. The agenda for today, we're going to give you an overview of Heroku Connect. Could I ask, just briefly, show of hands, how many people are familiar with Heroku Connect? Okay, so maybe about half people, so that's good to hear. We will, for those who aren't or maybe have passing familiarity, we'll give an overview of what the service is, what it does, its capabilities and benefits, and then some tips and tricks for how to use the capabilities of Connect before moving on to a demo. And we purposely structured this session so we minimize the slides and maximize the demo, so a bit more than half the time will actually be spent showing you the service in action. And then we'll finish by talking a bit about some of our customer success stories that actually frame some of our canonical use cases as well. And we'll do our best to leave time for questions. I will say, if there isn't enough time to answer all of your questions, we'll be available for questions outside, and we'll stick around to answer as many as we need as you have. So, all right, so what does Connect do? Connect is a data synchronization service. There's a couple modes in which it works. The sources and destinations are very well defined. One is Salesforce.org. The other one is a Heroku Postgres database, to be specific about it. And there's two modes of synchronizing the data, right? So you can do a physical synchronization of data, physically moving those bits. That's what we call data sync. Not surprisingly, and then there's what we call external objects. External objects implements the OData 4.0 standard. Essentially, it's a wrapper over the Postgres database. That enables another pattern you sometimes hear referred to as integration by reference. So those are the two modes in which Connect works. Those correspond to two high-level use cases, fundamentally, that we see with Connect, right? And so one is an application requirement. So imagine you're developing an application, a consumer-facing application, let's say, in Heroku. And there's a bunch of reasons why you want to be there, right? Because it's a polyglot environment. You can have your choice of languages and build frameworks and elasticity and all the benefits of Heroku, but you want to leverage the data from Salesforce. Or it could be you're lacking the expertise to work with the Salesforce APIs, and you want to get that data into a data store where there's broadly available knowledge. If you just think about, SQL there's hardly a more prevalent skill set around. So that's the use case for Connect Sync, is moving that data over from Salesforce to Heroku so that it can be leveraged by the application. And optionally, you can write that back. All right, so you can write data back to Salesforce, common use case, right? If you're creating a contact or a lead or updating customer information, that write capability becomes really important. Now with external objects, it's a little different view on that. It's we're going to talk a lot about Salesforce as our OData client application, right, via the Salesforce Connect framework. But it can really be any third-party client that is compliant with, knows how to work with the OData standard. And in this case, the data it's mastered in Postgres, right? So imagine that you're in Salesforce and you want to view and act upon data that originates in Postgres. So that's the use case for external objects, and that also supports writing back, right? So you're not limited to read-only. So just to summarize, Connect Sync, physically moving bits. It can be unidirectional, it can be bi-directional. As you saw in the title of the session, really scalable. We have customers that are in the, are having us manage many hundreds of millions of records and planning to go into the billions. But at the same time, it's super easy to set up, right? So rather than spending, you may ask yourself, hey, I could interact with the Force.com APIs. I can move data over, I can write data back. Believe me, there's a long tail of challenges. That space, that skill set for the API may be hard to find. Managing those changes over time is something that Heroku is able to do. Super easy. So setup time in minutes, and you get all the power of not only being in Heroku, but also working with the database semantics. External objects, again, this is the ability, this can be bi-directional, just like physically moving data, but it can be far more efficient for certain usage patterns. So if you have data that just simply isn't relevant to put in the CRM, or it's a large volume of data, but the data access pattern is just singleton queries. And we'll show some of that in the demo. It's not really efficient to physically move all that data over, right? So that's a fantastic use case for external objects. External objects are exposed in Heroku external objects, just to be clear, are exposed as Salesforce external objects, which largely behave as native Salesforce objects. So you get all the power, flexibility of being able to model that information in Salesforce. Some limitations like around triggers, but you get that without physically having to move the data over. And again, even easier to set up than sync. It's just a matter of a few clicks and a little bit of setup on the Salesforce side. We'll show you that in the demo shortly. Now, when you're comparing the two techniques, obviously Connect Sync is physically moving the bits over. External objects, it's direct API access. So it's a query and a response. The only latency there is the time it takes for the query to resolve. So at the time that you issue the query, the database receives it, you receive that consistent snapshot of the data as it is. So it works really well, especially for scenarios where you don't need to work with, let's say millions of records, at one time. With Connect Sync, typically we talk about the latency, as a matter of minutes. It's quite fast. You can configure it, as Howard will show you, to have a pretty low latency, but when it comes to actually reading data, right, moving it across the network, writing it to this, there's always going to be a notion of a cycle time. So there is some latency there, and that's why we talk about it being asynchronous or eventually consistent. It does take time to actually move the data over and the processing of the changes and such. Both techniques, again, we say that they support unidirectional or bidirectional. Another way to think about that is you can read the data and you have the option to write back using either option. Now, if you think about choosing between techniques, one question you may want to ask is, do you have to choose between these two? So we'll talk about that in a little bit. But if you were just evaluating the differences between when do I want to actually physically synchronize this data, or when do I want to sort of integrate by referencing the data that's stored externally? Well, with sync, Salesforce is the source of truth, right? By definition, we think we're bringing over the data from Salesforce, which is the system of record for the customer data. There's going to be, as an application, you don't own that. So when we say last writer to Salesforce wins, it means if you have built an application that also writes data back to Salesforce, you can't assume that there's not going to be other actors, whether those are users or system processes, that will overwrite that data, right? So that data is owned and managed in Salesforce, and as we talked before, there will always be some amount of latency with that synchronization. With external objects, Postgres is a source of truth. Another way to think about it is the application owns the data. And so as a consumer, let's say from the Salesforce side, from the client side in this respect, the benefits that you get are you're not redundantly moving over a lot of data. You're getting, the integration is as fast as the query can resolve. So, there's minimal latency. But here again, you have to understand that even though you may be writing data back to Postgres, you don't own that data. You're not in control of it. It's being updated by one or more processes externally. Now, the two techniques can actually be used together in a lot of interesting ways. So even if you're doing a bidirectional synchronization of data, there's the ability to leverage the rich modeling semantics of the database, let's say to create, you can think of it as a business object, right? A view across multiple database objects and then expose those back in Salesforce. Transformations of the data, aggregations, anything to support analytics. These are all things that you can do that are very complementary to sync, and in fact, is one of the things that Howard is going to show in the demo. So with that, I will turn it over to you for the demo.
All right. Good afternoon. So we're going to break the demo into two parts. We're going to show Heroku Connect Sync, and then we're going to show Heroku External Objects. With the sync portion of it, what we're going to show is the ability to synchronize your standard contact object out of Salesforce into a Postgres table and set it up for a bi-directional sync. Imagining, for the purpose of creating an app on, let's say, a mobile app on the Heroku platform that would enable your users to update their contact information and perhaps allow new users to register information for themselves. So we're going to start the demo. If I can slide over here. In Salesforce here, we have this standard contact object, which is near and dear to everyone in this audience, I'm sure. We have a few thousand contacts loaded up here, and that's going to be the object that we want to bring over into Postgres. So we're starting with Heroku Connect already set up a little bit. There's a bunch of setup that you need to do with your database and getting Connect attached to your Heroku app, but we're starting right here at the beginning of the provisioning process, which will allow you to associate your database, your Heroku credentials with Connect, and you're kind of setting up this triangle between the three. So with that behind us, let's get right into it. The first step is basically just selecting the database and the schema that you want to write your information into. It's important to note that you want to select a database that is appropriately sized for the capacity and volume of data that you plan on moving around. Here I've chosen a premium 0. Your use and mileage may vary. With that data set up, we just click the next button and we go out and interrogate the database, make sure that we can talk to it, make sure that the schema is legit, and we land here on our authorized connection page. And on this page, we basically select the version of the Salesforce API that we want to use. We default to the most recent version, and we recommend that you use that. But if you have other reasons to select an older version, you certainly can. And then you can also choose whether your org is a production sandbox or a custom domain. In this case, we're just going to use production, and we're going to continue on. I'm going to click the authorize button, and it's going to take us over to Salesforce to basically do our OAuth setup here. I have an account all set up here. Find it, scroll down, whoops. Got to type that in correctly. All right, let's do that one more time. Search. There we go. And with that, I will log in, and I'll be brought right back to the Connect dashboard with basically the provisioning process behind us. At this point, what we need to do is set up our mappings. Setting up a mapping is basically telling Connect that I want you to work with the Salesforce object and pull the data into Postgres and optionally set it up for read-write. So in our case, we do want to set it up for read-write, and let's just get started with that. In order to create a new mapping, and you can create as many mappings as makes sense for your use case, we click Create Mapping, and we go out and we interrogate all of the Salesforce objects in your org. In this case, I'm particularly interested in the contact object, so I will search for it. So in this screen, we're listing any Salesforce objects that have contact in their name. I'm interested in the contact object proper, however, so I select that, and it brings us up to the configuration page. And this is where I'm going to be setting the configuration for this particular mapping. We have a few pieces of information that we need to specify. The first one is the polling frequency. Connect is a polling-based product, so I can set the polling frequency anywhere from 2 minutes to 60 minutes. I'm going to leave it, right around 10 minutes here. And if you want to expedite the polling, you can basically click this option, which is listen for updates using the streaming API. When you select that, we create a push topic, and we listen and subscribe to that push topic, and whenever an event happens on that object, we get notified, and that triggers Connect to poll right then and there. So you can up the polling frequency to, we say near real time. It is not real time, but it's as quickly as we can do it. For this mapping, I'm going to select it because I want to do that. The next option we need to think about is whether we want to write updates that occur in our Postgres database back to Salesforce. So I'm going to select this because we want to write an application that would allow our users to update their contact information and have it go back to Salesforce. Remember, Salesforce is our system of record, our source of truth here. And it's no more really complicated than that. So anytime I do an insert or an update into that Postgres table, these updates are going to go back to Salesforce, and we will make sure that we reconcile, all of the SFIDs and all that type of stuff. The last unit of work here to create a new mapping is basically selecting the fields that I want to map. Here I'm just going to select a few. Email, I'll select first name, last name. I'm interested in the user's mailing address right here, so I'll select mailing city, mailing country, skip the latitude stuff, do state, street, and how about we'll do the mobile phone, and we'll also do the phone. And setting up a mapping is no more complicated than that. We ask that you give consideration to the fields that you map. I mean, you can map as many as makes sense to you. If you go above 100, we'll warn you, but we don't have a hard limit on the number that you can map. We'll go ahead and click save, and Connect goes to work, starting to pull that data down from Salesforce and load it into the Postgres table that we've just created for you. So that's going to take a little bit. It's going to take less than a minute. But during that time, let's go over and look at the log viewer. We're going to sync about 5,000 rows. And the log viewer allows you to view all of the activity that Connect is doing on behalf of keeping your data synchronized. And this data is going to update in real time. So if we scroll to the bottom, we can see that we created this table. We started a reload process, and we can actually see that we are querying Salesforce and bringing this data down. And we can see that we've already brought quite a bit down. In a moment, we'll see that the reload is complete. But instead of waiting for that, let's talk about the Salesforce error section right here. I'm going to click over to here. I expect it to be empty because I haven't written anything yet. But the Salesforce errors is where you would go to view any errors that have occurred writing data back to Salesforce. And these errors would result from a validation constraint that got violated writing data back to Salesforce. Let's say that it had to be blue or green, and you tried to write yellow back. That would be an example of where the write failed because of a Salesforce violation. Here we can see the load is complete, and we're done. We can filter based on all of our objects or just a single object. We've only got one object mapped right now, so we're only looking at the contact object. If we go back to the overview page, we're going to see that we are now in a good status of OK, and we've synced 4,993 rows from Salesforce, and we see that we have a matching count in Salesforce and Postgres. And at this point, you can start reading and writing this data to your Postgres table using your app that you've developed on Heroku. So we actually can do this at pretty high scale. Here's an example of a connection where we've got a few mappings that have many millions of rows. We have an account object here that has over 4.8 million rows under management, and we have a contact object with over 10 million rows under management. So we can do this at scale really well. What you're looking at above is a histogram of the activity that's occurred over the unit of time that's been selected here. Right now, we're looking at an hour. This is basically showing you the number of writes going to and from Salesforce. So, in the top part, we're looking at updates from the database to Salesforce. In the bottom part, we're looking at the updates from Salesforce to the database. We can change the unit of time here very easily. Let's go to 7 days. And, we're now looking at day unit granularity. The graph is really handy for spotting anomalies. It's not just pretty eye candy. In the example here on June 25th, we can see that we had quite a bit more activity than we normally have. We're usually pretty consistent. So as an administrator, that could be something that you might want to look at and drill into. a little bit. The last thing I want to show you here is our Explorer feature. The Explorer feature allows you to basically explore the data. So you're looking at the data that exists both in Salesforce and in Heroku Postgres. Here we're basically pulling this data directly out of Postgres. We can do searches for it. I'm going to search for myself here. I find two Howards, Howard Jones, neither one of which are me, but I can easily drill into it and take a peek at that data under the hood. And we're pulling this data from the database and from Salesforce in real time, so you can easily compare the data. Hopefully you're not going to see any differences, but you can see differences from time to time, particularly if you're doing writing and you had some kind of violation writing back to Salesforce. You can search on any number of fields. Let's just pull this SFID out of here. So if you were in Salesforce and you knew the SFID and you wanted to go over to Postgres and find it, this is a really handy way of doing it. And you can see that I found the one entry there. So that's basically setting up Connect. It's no more complicated than that. It's a pretty straightforward process. You identify the mapping that you want to synchronize into Postgres. You set up some configuration options, and Heroku goes to work and does it for you. And you get to write your app using your language of choice. So with that, let's switch gears and go take a look at Heroku External Objects. For the purposes of this demo, what we want to have you think about is imagine you've got some real granular, detailed data that you've accumulated in a large table. This could be sales data. This could be IoT data from a sensor. This could be behavioral data from your web clickstream. It could be anything that you want. And perhaps you want to run some analytics on it. You want to do some aggregation, and you want to expose that back to Salesforce. And you want to use Salesforce's modeling capabilities to associate it with, let's say, the standard object account, so that when you're looking at an individual account record, you can actually drill in and view this detail. And so what we're going to do for this demo is we actually have some sales data that we're going to aggregate using a basic Postgres view that we're going to expose back to it. And we'll get to that in just a moment. Getting Heroku External Objects set up is pretty straightforward. I've already done a little bit of the setup. If I hadn't, instead of this button where it says reset and email user password, it would say create. And with that, I'm going to get an email which contains my endpoint and my credentials that I'm going to enter into Salesforce, and I'll show you that in a moment. Below that, we have the endpoint URLs, and these are the URLs that Heroku External Objects is exposing to your OData consumer. In our case, the OData consumer is Salesforce, and so we'll be entering that into Salesforce. And below are the data sources that you can use for pulling this data and exposing it back to your OData consumer. We're going to expose 4 tables, the account, contact, and if we scroll down a little bit, we'll see that we've got the account sales and the customer object that we're going to be exposing in this case. Basically, this list consists of all of the tables and views and all of the schemas in the database that you've connected to Heroku Connect. So it can be a pretty exhaustive list depending on what you've got set up there. Real quickly, just to make this a little bit more real, let's take a peek at Postgres. And I'll show you the account_sales view that we're going to actually expose back to Salesforce. If I sales.account sales, all right, there we go. So I'm going to basically show you the definition of this view. It's a very basic query. It's basically summing and counting this detailed sales data from this table, and it's really pretty basic, but it could be a lot more complicated depending on your use case. We have 3 columns here. Just take note of them: ID, total sales, and number of sales, because when we get over to Salesforce, I'll point those out and you can see how they all kind of connect together. So let's jump over to Salesforce real quick and go into the setup page and look at those external data sources. So I'm going to search here for external. And there I find external data sources. So right here, I'm looking at all the external data sources that are associated with this Salesforce org right now. We have 5 of them. The one that I'm interested in for the purposes of this demo is this middle one right here. I'm going to click on it, and we can actually scroll through and look at some of this configuration data here. We have the endpoint URL, which, if you recall, is coming from right here. One thing I should mention, we support 2 versions of OData, OData 2 and OData 4. We are in the process of deprecating OData 2. You really do want to use OData 4. It's a lot faster, number one, but it also supports read-write, which is a wonderful capability. So we are entering that endpoint URL right here. I've already configured this. If I hadn't, the process would be pretty similar. I've set it up for read-write, so if I'm reading or writing, if I'm writing to one of these objects, they're going to make their way back into Postgres. And then if I scroll down, you can see the 4 data sources that I exposed over in Heroku External Objects are appearing here. The one that we're interested in for this demo, we're calling External Sales. It's coming from the account sales view that we looked at, right here. And remember these columns right here. If you scroll down a little bit, you'll see that they're right here. We have the ID, the total sales, and the number of sales. What's really neat about this is we can use Salesforce's modeling capabilities to actually associate this back to the account object. So the ID is actually the SFID of an account record. And so I've defined the lookup here. And so now when I look at an individual account record, I can drill into it and see this sales detail. And let's do that. Let's go over to our account object. And we'll load them up. We've got a bunch viewed recently. Let's just view them all. Scroll down and we'll find, advanced communication sounds like a good one. And we'll drill into it and voila, there's my sales total and my total number of sales. Now remember, this data does not live in Salesforce. This data is being pulled in real time using Heroku External Objects. And so if I actually take this external ID and I come over here to Postgres and I just do a basic select star from sales.account. Am I typing that right? Well, I'm going to cheat, and no, it's going to be in my history. There it is. And I type that in. There we go. You can see the actual values right here in this table. So if we go back, remember we have 357. Go back to here, we have 357 and 1.2 million in total sales. And so that is, the power of Heroku External Objects. It's very complementary to Sync. It's a different use case, but you can do some pretty crazy things. It's even possible to sync some data over using Heroku Sync, run some analytics on that data, write that into a second table that you then expose back via OData into your Salesforce org and associate it with your objects and get some rich power there. That is basically Heroku External Objects and Heroku Sync. And with that, I'll turn it back to Rob.
Can you flip it back? Thank you very much. So let's get our context. Excuse me, it's, there we go.
Yeah.
It's always a glitch. So I love that external objects piece, especially. We've got a number of customers that use that in really interesting ways. One customer in particular, they have 20 million coupons, right? And so they do the association between the customer and the coupon over in Heroku. That logic happens there. And then they expose that information using external objects within Service Cloud, right? And so they're able to just query and see the coupons associated to a customer rather than moving over 20 million coupons every day, right? That wouldn't make much sense. Howard has a super fancy refrigerator that can phone home and tell him when the door's open. And you imagine the amount of data that's being generated for every refrigerator that's in the field every day, right? completely bad idea to push that to, all that to Salesforce. However, when there's an issue, imagine again a Service Cloud scenario, being able to look up Howard and seeing, critical errors in the last 24 hours, or really anything you might want to view in terms of that event data. So a ton of power there, and again, very complementary with Sync. And as you saw, it's really easy to set up, right? So I mean, you go through, it's just a matter of minutes. You can get the data set up really, synchronization set up really quickly. You can define external objects super easily, and then you're off to actually delivering business value. And I think that's one of the most compelling things about Connect, is it allows you to, solve that data integration challenge and get focused on actually solving the business problems. So a couple of things that aren't obvious that I want to share with you about Connect. Connect is really intelligent about dealing with your data shape, your data volume, write patterns if you're doing that, read patterns. So we're able to, under the covers, switch between different Salesforce APIs. We're able to, and we do intelligently adjust batch sizes. Everything is parallelized. So the system at every level in the stack is highly parallelized. A lot of work and thought has gone into making it as fast and as robust as possible. And baked into all of that is a deep knowledge of Salesforce, and we stay current on that. So the system understands the Salesforce data model. The system understands the Salesforce APIs. It deals with the various idiosyncrasies. It implements the best practices. Again, it frees you up from having to worry about some of those low-level details. So let's talk about a few of our customer use cases. There's 3 that I've picked to share with you, and I think they're interesting because each represents a canonical use case for Connect. All right, so Red Robin is one such example. And I think of this as, they built they had a V1 loyalty app that was built on, fundamentally just built on Salesforce as the data store. They ran into some scalability issues. The developer velocity wasn't quite what they wanted. By moving over into Heroku, they gained a developer velocity. They were able to use Connect to move the data and become the foundation of their data architecture, along with Postgres. And by all accounts, it's been a wild success for them, because users go in, they have this app, they walk into the outlet of Red Robin, they're recognized, and they get these custom offers that just create, anonymity is the enemy of loyalty, right? So they're recognized, they get an offer, and they feel pretty good about it. So Monsanto, this is another very common use case, which is Salesforce org consolidation. So as you know, Salesforce often begins its life in one or more departments, eventually typically becomes the enterprise standard, but you'll have oftentimes many Salesforce orgs within the enterprise. International subs, acquisitions, those are other cases that sort of lead to that result. But you almost always see 2 requirements, and they usually come in sort of a sequential order. One is the need to have some common view, right? A holistic view across all of these orgs, right? And the other one that happens sometimes is to actually wanting, desire to have everyone move into a central org. And both of these applied to our friends at Monsanto. They leveraged Heroku Connect and Postgres to bring in the data from all 11 orgs, did a bunch of modeling and transformation in Postgres, and then streamed that information out to a central org. And as you can see, there's a lot. It's a small diagram, and there's a bunch of components, and Kafka and Lambda, and it's a very involved project that they did. But at the core of it, right, they had to get the data from Salesforce, and that's where Connect sat there. Last one. This is Forever Living, and sort of the canonical use case here is analytics, right? So they're bringing in data from a bunch of different operational systems, landing it in Salesforce, syncing it over to Postgres using Heroku Connect, and doing something conceptually similar to what Howard showed you, which is defining all kinds of analytics, right? As a part of that, they were doing transformations and reshaping the data, and then they're exposing that back into Salesforce. Okay, so in conclusion, I hope you guys were able to see that Connect is again 100% managed service, very, very scalable, very high performance. 2 data integration services in one. So that first act was sync, second one is external objects, and hopefully we'll be talking to you about the next one at Dreamforce. And with that, I want to just make one plug. If you happen to be on the Heroku track, there's one more Heroku session happening today at 2 o'clock with HerokuEnforce.com. So highly encourage you to check that session out. And with that, I'll open it up for questions. With you, sir. Do we have a microphone? 2 or 3 questions. Okay, so after those questions, we'll just quickly pack up and go outside the hall. We can answer any additional questions for you there.
Thanks. So what you just demoed, are there APIs to do that as well?
Yeah. Do you want to talk to that?
Yeah. So we have, we definitely have, most of this available. Most of what 100% of the dashboard is powered by an API, and a good chunk of that is available for third-party use. So you can do all of the provisioning, connection setup, mapping setup, and all of that via our API. Some of the things you can't do are monitoring the log viewer and a few of the administrative type of stuff. But we've made sure that our API is sufficient that you can script 100% of your connection setup and management.
Okay. There's also a CLI, just so
yeah.
So you know. Yeah.
So big Heroku users, and I use Connect and Salesforce Connect and Heroku Connect. And I don't know if you can share some best practices. So big issue I have is when I change a field name or I delete a field, so it usually crashes the API, right? Because I have to reload the tables in Connect. So I don't know if there's any best practices on so it doesn't crash the API.
Yeah, I mean, I think that probably is, as much a factor of the language and the environment you're using, and whether your ORM is forgiving to changes, in the underlying database or not. I mean, some ORMs are very, very strict and rigid about that, and other ORMs are pretty forgiving. So I would say a best practice is probably doing it, of course, in a staging environment, first. And probably, staging your commits, in multiple steps. When we have to make changes to our database, we typically have to do them in multiple steps so that we don't incur any downtime. And so that would probably be something you might want to explore also.
Yeah. And anytime you suspect that it might be a Connect issue, don't hesitate to open
Yeah.
up a support ticket, so we can investigate. Okay. Last question before we'll go outside for the more.
You just mentioned it, but what does log viewing and event monitoring look like? Is there somewhere online I can see a demo or something of that?
Howard showed
Yeah,
that.
we demoed that.
Both are earlier, but we could, if you want, we can show you more at the booth as well. Okay, thank you everyone. We'll go outside for any additional questions.